Hi friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Wadekar from Matoshi College of Engineering and Research Center, Nasik. Students, today we are going to start unit number 1, that is your data communication and network models. So the content of unit number 1 is that is basics of data communication. What are the types of signals? Then we have to study different signal conversion methods as like your analog to digital, digital to analog, then analog to analog and digital to digital conversion methods. Then we have to study bandwidth utilization, data rate limits, what is multiplexing, why there is a need of multiplexing in data communication, and if it is so, then what are the different multiplexing techniques are there? Then data rate limits, what are the topologies, how topology it is going to affect the network, what is noise, the types of noise, then Shannon-Hartley theorem, channel capacity, what is Nyquist theorem. Then we have to study the networking models and addressing as like your OSI model, that is your open system interconnect model, your TCP/IP model. Students, the reference that we have used for this unit is your BA 4ism, that is data communication and networking, which is of 5th edition. You can also refer 4th edition also. Now, what are the objectives of this first unit? So, the objectives of this unit that students are expected to be able to understand basics of data communication. Then, what are the types of conversion of signals? Understand what is multiplexing, what are different multiplexing techniques are there. Then they should understand Nyquist theorem and Shannon theorem, Shannon-Hartley theorem, and last they should understand the most important model, that is OSI and TCP/IP model. On completion of this unit number 1, students now would be able to understand the data communication. They could understand the multiplexing and topologies. Even they can recognize the topologies that has been used in their colleges, in their labs. They can understand noise. After this, students should understand the importance of Shannon-Hartley theorem and Nyquist criteria. They understand open system interconnect and TCP/IP model. Students, today we are going to discuss about introduction to data communication, topologies and categories of networks. So first we would start with data communication. So information which is presented in whatever form is agreed upon by the parties creating and using the data. So data, it could be in the form of your image, it could be your text, it could be audio, it could be video. Then what is data communication? Then exchange of such data between two devices via some form of transmission medium is your data communication. And in communication, most of the time we use a telecommunication, guys, as like in your electronics and telecommunication. Tele, it is a Greek word. It means afar. That is the communication which is going to take place at a distance. So in data communication, which is also taking place around the world, around this globe. So it is all about your data communication. What are the guys fundamental characteristic of your data communication? So first it is your delivery. It means the system should deliver the data to the intended user, that is to the correct destination. The data received, it should be by the intended user or the desired user. After that one, accuracy. That is, data must be delivered accurately. Data that is altered or changed during the transmission, and they are useless, no use of that one. So data, it must be reached to the user accurately. After that one, it is your timeliness. Timeliness in the sense the data it should deliver, or data should be delivered in timely manner. As it is produced, it should be delivered, because any delay in those data, it would be useless. If I'm going to have a real time communication, I'm talking with you, and if this communication, it is going to be reached to you having some delay, then there is no use of that. So data must be, as it is produced, it should be delivered in similar manner, in the proper sequence. That is your timeliness. So it is useful for your real time transmission. Next, it is your jitter. What is jitter? Basically, variation in the packet arrival time, or we can say variation in the delay of the packets that has been received. Suppose few packets, 5 packets are there, which is going to be produced by the sender, by the source, and there are 5 packets are there. Each packet, suppose it has some delay. Suppose 5 packets, they have a delay of 5 milliseconds. Then they are going to be reached to the destination with a constant delay of 5 milliseconds. But if jitter it is there, few packets, initial packets, suppose they have a delay of 5 milliseconds, mid packets they have a delay of 20 millisecond, then it may happen that few packets or earlier packets, they are going to be reached with a significant delay, whereas the mid data or the end packets, they have been received earlier. So there is not a proper sequence of the data, it is there, data packets are there. Understood? So it means there is a variation in the packet arrival time, so it should not happen. So it is all about a jitter. Now, what are the 5 components of your data communication? So you can see from the figure that there is, first it is your a message. Message, that is the information or the data that to be communicated. So message, it could be in the form of your text, it could be in the form of your numbers, images, audio or videos. Next, it is your sender. Sender, it means which is going to send the data. So sender, it could be your computer, your workstation, your mobile, your laptop. Next, it is your receiver. Receiver means the workstation which is going to receive the data. Again, receiver, it could also be your mobile, it could also be your telephone, your laptop, right? Next, it is your transmission medium. That is a physical path by which a message it is going to travel. And remember, the medium, it could be wired, it could be wireless also. And last, it is your protocol. Protocol, it means it is a set of rules that is going to govern the data. Because guys, without protocol, it would just like we have connected two devices physically, but they are not going to communicate it. In a same manner, when two person they are going to connect it, one person it is going to talking in Japanese and another understand French. So what does this mean? He is talking in Japanese, he understands French, then there is just they are connected, they are not communicating. So what is the common language that they could understand? It is English. So that is a protocol that is going to govern the data transmission, that which all the data communication, equipments, all the manufacturers while manufacturing it, they should follow those protocol so that the devices from the different vendors, they can communicate easily with each other. Now, the next, it is your direction of a data flow. As you can see from the figure that There are three types of data flow. It is there: simplex, half duplex, and it is a full duplex. So simplex communication, in the sense, it is just a one lane traffic, right? It means the data can always be transmitted from one direction only. As you can see from this figure, the data, it is going to be transmitted from this mainframe computer to this monitor. This is your simplex communication. As like your keyboard, it only give the input to your computer, that is simplex communication. Your monitor, your screen, it could always display the data, so it is an output device. Your mouse, it is there, it is going to give the input to the data. So it is all about what? Simplex communication. Next, it is called your half duplex communication. In half duplex communication, the communication or the transmission and receiving is possible but not simultaneously, guys. At a time, you can either transmit, this station either transmit or it could receive, but not simultaneously. So, example, it is your walkie talkie, right? So at a time, either you can talk or you could listen. So it is a half duplex communication. And full duplex communication, in the sense that both the parties, both the station, they can transmit and receive the data simultaneously. So let's see in brief. Simplex means unidirectional communication. As I already told, it is a one-way street. As like your keyboard and monitors, your mouse, these are the examples of your simplex communication. Next, it is your half duplex communication. They can both transmit and receive, but not at the same time, like a one lane road, that is with two directional traffic. At a time, if the car it is passing in one direction, then others uh, traffic or car, they should wait. Similarly, example, it is your walkie-talkie or your citizen band radios. Next, it is your full duplex communication. In full duplex communication, they can transmit and they can receive the data simultaneously, as like your two-way street. Telephone network, it is the best example. Your mobile phone, you can talk and you can listen at the same time. So in this one, the entire channel capacity, it is divided in the two direction, because two station can transmit and receive. Whereas in half duplex, the entire capacity, it could be utilized by either of the station at one time, right? Now, what is network? A set of devices or nodes connected by communication links is nothing but your network. Then what are nodes? Your computer, your printer, or any device which is capable of your sending or receiving the data, your mobile phone, data terminals, these are what? Nodes. Then, to be effective and efficient, a network must meet a number of criteria. That is performance, reliability, and your security, it is there. So basically, performance, it can be measured. Performance, it can be measured in many ways, including your transit time and response time. So transit time, what does it mean? It is the amount of time that is required for a message to travel from one device to another. And what is response time? It is the elapsed time or happen time, finish time between an inquiry and a performance. So the performance of network, it depends on the number of factors, as like your that how many number of users are there, then what are the types of transmission medium, capabilities of connected hardware, and the efficiency. Then next, it is come your reliability. Guys, reliability basically it is measured in terms of what? Your frequency of failure. That is the time it takes to recover from a failure. That is, and network robustness and catastrophe. If anything, suppose your the network some due to some congestion or any link failure, the data communication it is not going to be taken place through that link. So how much time it is going to take to recover from that failure, and again we could use that link. It is nothing but your reliability. And next guys, it is your security. Security, it means what? Protecting data from your unauthorized access. So hope so you understood the network criteria. After this one, types of connection. Basically, there are two types of connection, that is a point-to-point connection and multi-point communication. Now you can see that point-to-point connection in the sense what? Two stations are connected by a dedicated link. Dedicated, it means what? The entire traffic it is going to be traveled through this link. No third station it is going to utilize this link. That is a point-to-point communication, right? And what is multi-point communication? The link it is shared among different stations. That is your multi-point communication. So you can see from the figure that three stations are going to use this common link. Now, point to point, it means dedicated link between two devices. So the entire capacity of the channel, it is reserved between these two devices. And the best example, it is a microwave link and your TV remote control. When you are going to change the channel of your television by means of remote due to this infrared communication, this is called a point-to-point communication. That communication, that remote, it is not going to change the channel of another electronic devices or another, different television. Next, it is your multi-point, that the more than two devices share a single link, and the capacity of the channel, it is either a specially share or time share. Specially share in the sense what? All the devices, they are going to use the link simultaneously. Whereas time share in the sense what? On time basis, on timely manner. That for a few millisecond, few seconds, one station it is going to utilize the channel, and after that another station. That is turn by turn, they are going to use this link. Now, the next topic that we are going to study, it is your topologies. So what is topologies, guys? Topology, it means it is how your network it is being physically laid out. The geometrical representation of the relationship of the link that those are connecting those devices. So the topology, it could be mesh topology, it could be star topology, it could be bus or ring topology and hybrid topology. So we would start with mesh topology. As you can see from this figure, that dedicated point-to-point link to every other nodes are there. You can see there are 5 nodes are there, and each node has a dedicated link with each other. After that, suppose if we are going to consider the link between these two stations, it is a full duplex communication, and suppose there are n nodes are there, then how many links we required? We required n into n minus 1 upon 2 links. Understood? In this example, if you have taken a 5 stations, right? 5 stations are there. So n equal to 5. Then n into n minus 1, that is 5 into 4, 20. So 20 links are required. But if those links are full duplex, then 20 divided by 2, that is 10 dedicated links we required. And each station should have n minus 1 IO ports because it has to connect to n minus 1 nodes. So definitely this station, it should have 4 ports because n over here is equal to 5. So 5 minus 1, that is a 4 IO ports we require. Advantages: no traffic problems because they are going to be shared by this dedicated link. No other station it is going to utilize this link. So robustness it is there, security it is there, and easy fault finding and isolation it is there. That which station it gets faulty, then you can easily determine that one. But the difficulty, the disadvantages with this topology, it is this, that installation and reconfiguration, the space it requires, the cost, everything. Guys, practically it is very impossible. It is possible for small network. But for inter-network, whether it is possible, if I'm going to communicate with all of you, then is it possible to have a dedicated link with each of you guys? No, it is not possible. Practically, it is impossible, right? From all the point of view, from space, from configuration, from cost point of view, it is not possible. So next topology that we are going to see, it is your star topology. So you can see over here, it could be a hub or it could be switch. So dedicated point to point link only to a central controller, that is called a hub or switch. You can see the different stations are there. So these stations are going to communicate to each other via this central controller. So this switch or hub, it acts as your exchange. No, there is a direct traffic between these devices are there. They need to communicate through this switch or hub only. Advantages, definitely as compared to mesh topology, it is your less expensive and robust, right? And disadvantages, the major disadvantage of star topology is that dependency of the whole network on a single point, on a single controller. If anything happens, if anything damage happens to this hub or switch, entire network would get collapse. But remember guys, in all your laboratories, most of in all the colleges or everywhere, majority we use star topology. Next, it is your bus topology. So what is bus topology? So you can see the figure how the bus topology it is there. One long cable it is there that is going to link all nodes. You can see this is your backbone cable, it is there end to end, which has been shown, and these are the stations which is going to be connected to this backbone cable by means of this tap and this drop line, and this is the cable end. But it has a limit on the number of devices due to the distance between the nodes. Advantages of bus topology that it is easy installation, it is there, cheap it is there. But disadvantage, again, it is a difficult reconfiguration. For a large or longer distance, you couldn't use this bus topology. Fault isolation, it is very, very difficult. Even a break or a puncture in happens in this backbone cable, it is going to stop all the transmission. And problem it is there, when the signal unit it is going to travel from this one tap to another tap, there is an energy loss it is going to take place at this points. So those signal energy it would be lost in the form of your heat, right? So this is a major disadvantage also of your bus topology. So we couldn't use for long distance communication. Next, it is your ring topology. So you can see over here dedicated point to point link only with two nodes on each side. You can see this station, it has only 2 points, two dedicated link it is there to this station and another to this station. Similarly, it is applied for all the stations. And the data it is going to be communicated in one direction only, either clockwise or it could be anti-clockwise. So we need to use a repeater over there, okay, in order to repeat the signal, reproduce the signal as it is. So advantages, easy reconfiguration it is there, fault isolation it is also easy, but unidirectional traffic it is there. But a break in the ring cable, it is going to disable the entire network. So for that purpose, you can use a dual ring also. Dual ring in the sense what? If one ring it is going to get damaged, you can temporary basis, you can use another ring. So it is a ring topology. Next, it is your hybrid topology. Hybrid topology, it means what? That it is going to combine several topologies. As like you can see that this is a main star topology there. This is a hub and main it is star topology it is there. And each branch it is connecting several station in bus topology. This is your bus topology. Because several station it is going to utilize this link via this tap. So this is also bus topology. over here this one, and they are connected by means of this star topology. Why we are combining? So that we can combine the advantages from various topologies. So it is all about your topologies. Now, the last topic of today's you know the module, that is the first support of the module. First, it is your categories of network. Now you can see the network. Basically, it is, you can heard about this LAN, MAN, and WAN. So network, basically it is classified as your local area network, metropolitan area network, and wide area network. Basically, local area network, it is designed for a single office or for a single building or a campus, which is a very less than a few kilometers, and usually, it is a privately owned. So commonly topologies that you are going to use for LAN, it is could be your bus topology, it could be ring topology, or it could be your star topology. Over here you can see that the 12 working computers are there, which is connected to this hub, right? So it is a local area network. A small, just a network between your mobile and your laptop, it is also LAN. The connection between your printer and your computer, it could also be a LAN. Or you can use, more devices, your mobile, your different workstations, laptops. They can also make a local area network, but whose vicinity, whose area, it is less than that of a few kilometers. Next, it is your metropolitan area network. So in metropolitan area network, you can see from the figure that it is designed, to extend over an entire city. So your a single network such as your cable television network, it is there, which is going to connect a different LANs. You can see this is a different LAN, it is there, and it is going to be connected into a larger network so that the resources may be shared. A particular company which can use a metropolitan area network to connect its LAN in its office throughout a city. So which could be owned by a private, or it could be owned by your public company. Next, it is your wide area network. So wide area network, it provides what? Long distance transmission. That is country to country or continent to continent. And basically a WAN, it is owned by a, one company. They may utilize a public or lease or private communication equipment, usually, in combination, and therefore a span and what? Entire number of miles, whole area, whole continent, different continent, they can connect by means of this wide area network. Next, guys, it is your internet. You have heard the name internet. So two or more networks are connected by means of inter-networking devices. You can see from this figure, different networks are there. LAN it is there, MAN it is there, WAN it is there. The connection or interconnection of all these devices, all these networks, it is nothing but your inter-network by means of this routers, gateways, firewall, etc. So a network, basically it is a group of what? Group of communicating devices such as your computers or printers. And internet, which is, shown in this lower case, it is a two or more networks that can communicate with each other. But the most notable internet, that is in capital I, which is in uppercase, it is a collaboration of more than hundreds of thousands of interconnected networks. So, the private individual as well as the government agencies, schools, research facilities, corporations. So, even 100 countries, they can use this internet. You can see from this figure, it is also called as a heterogeneous network because WAN, MAN, LAN, different networks we are going to connecting to each other. You can see from this figure that four WANs are there, two LANs are there. This is LAN 1, LAN 2, and four WANs are there. This is point to point WAN, it is there. It is a switch WAN, it is there. Again, point to point WAN. This is point to point WAN, it is there. So it is all about your heterogeneous network. And due to this network, guys, internet, that it has revolutionized many aspects of our daily lives. It has increased, affected the way we do business, the way we take education now, our luxurious time, that how we are going to spend it on social networking sites. So internet, basically, it is a communication system that has brought a wealth of information to our fingertips. Just by means of Google search or any search engine, you can have the information instantaneously. So we would have a just a brief history of internet. That is in 1967, guys. That is ARPANET, a small networks of connected computers, which is proposed by what? That is your DoD. That is Department of Defense. They have found the way to connect computers so that the researchers they funded could share their findings, reducing cost, eliminating duplication of efforts. For that purpose they have made ARPANET, that is Advanced Research Project Agency, ARPA. And the networks formed by those, it is called your ARPANET. Then, guys, in 1969, as the time passes, the technology advances. In 1972, 1973, Windcuff and Bob Kahn, they proposed, they actually, both of these, they were a part of this ARPANET. They collaborated on what they called, that is interneting project. So they have outlined the protocols. They have published the paper. And this paper on this, basically, guys, TCP, that is a transmission control protocol, which includes some concepts such as encapsulation, your datagram, functions of a gateway. And later on, they divided this TCP into two protocols, that is separate protocol, that is TCP and IP, that is transmission control protocol and internetworking protocol. So guys, today we have seen what is data communication, what are the fundamental components of data communication, then what are the characteristics, then we have seen the topologies, different topologies we have seen, categories of networks, LAN, MAN, WAN. And this is the assignment. So please note down this assignment. In next module, we are going to study about the types of signals, digital signals, and what is multiplexing and what are the different multiplexing techniques are there. This is my email ID shown on screen. For any questions or feedback, you can post it to my email address. So it's all about today's lecture, guys. Thank you very much for the lecture. We will meet in next lecture. Thank you.